All right, so we're going to look for critical numbers. It says to approximate the critical numbers of the function shown in the graph. So remember, your critical numbers are going to be where you have a cusp, which means your derivative is undefined, but your original function is not. It's going to be where your derivative is equal to 0, which means you'll have a horizontal tangent line. Okay, those are going to be your critical numbers. So I would like to know what my critical numbers are. Well, this has an open circle on it, and so does this, which means I cannot use my endpoints. So remember, your endpoints are off limits, which means you do not have the lowest values. You do not have minimum values, because no matter how close you get to that axis, I can get you closer without touching it. So the only place that you're going to have a critical number is where this thing maxes out, which is going to be an x value of 0. So you should have a critical number at x equals 0. Do you have a max? Yes, I do. So my relative max occurs at 0. Do I have any minimums? No. I do not have minimums. Do I have an absolute max? Yes. Do I have a very, very, very tallest point? My very, very tallest point occurs at an x value of 0. I don't care how tall it is, meaning don't tell me the y coordinate. I just care where it is, and then that occurs at an x value of 0. Do I have absolute mins? All right, so let's clarify this. If these were filled in circles, in other words, if I could include my endpoints, or if this was a closed interval, which it is not, then I would have minimum values, and they would occur at -2 and 2. I still couldn't say that they are relatives because relatives cannot include the endpoints. But since this is an open interval, I will never, ever, ever hit the axis, but I can get infinitely close. So you do not have any absolute mins. And so let's practice another couple. Let's go to the end for a second, and then we'll come back. All right, so here's my question. If I am looking at this pretty picture, I would like to know what these values are. So remember, for relative maxes or mins, which we have over here, for relative maxes or mins, they cannot be the endpoints. Absolute maxes and mins can. And then the absolutes will be the very tallest and the very lowest. Okay, so look at A. A is an endpoint. He is allowed, if he's included, he is allowed to be an absolute max or min. So is he a very lowest point? Yes, he is. So he is an absolute min. Okay, so look at B. Is B the absolutely tallest point? Now you might think it is, but it's not, because look over here. If I compare across the way, there are points that are taller than B. So B is not the absolute tallest point. That means B must be a relative min. Or sorry, relative max. Just kidding. All right, C. C is nothing. C is there to throw us off. He is not a tall point. He is not a low point. He is nothing. Okay, look at D. He is a low point. He's not the lowest point. So he is going to be a relative min. And then look at E. He's a tall point. He's not the tallest. So he's a relative max. Look at F. He's a low point. He's not the lowest point. So he's a relative min. And then look at G. G, you would be tempted to say that he's an absolute max, but you never get completely up to that value because it's not included. So again, G is nothing. G is not a max because I don't have a final value for him. And so he's done. So now if we go back and just start looking, what we want to do is, hang on. All right, so I want to start looking at some of this and start getting some sort of system going so I can figure out what is happening. So I want a critical number. A critical number of this function is going to be, first of all, is he smooth? Yes, he is. I don't see any radicals. Is he continuous? Yes, he is, because I don't see any variables and denominators. So the only other alternative is going to be, where does my derivative equal 0? So the derivative of my function is an 18x minus 9. And I'm going to, oh, sorry, good heavens. He's at 12x minus 9. I don't even know what I just did. All right, he's at 12x minus 9. And now I'm going to solve that for x. So I'm going to add 9 to both sides and then divide by 12, which means I get x is 3/4. So you have a critical number at 3/4. Now think about this for 1 second. This is a parabola that opens upwards. So you know that he looks like this. Well, he has a minimum value right there because it's a bottom, it's a low point. It occurs at 3/4. You just found the x-coordinate of the vertex. So that's another alternative way to handle that. All right, so number 6, same thing. Finding the critical numbers of the function. Is he smooth? Yes, there's no radicals. Is he continuous? Yes, there are no variables in denominators. So I'm going to take a derivative, which is going to be a 9x to the 8th, because that's my last option, is where does my derivative equal 0? And I get a 63x to the 6th. So I'm going to go ahead and divide out everything by a 9. So that's going to leave me with an x to the 8th minus a 7x to the 6th equals 0. I just divided everything by 9. And now I want to solve. So what I have is I can pull out an x to the 6th, and that's going to leave me with an x squared minus 7 is 0. So I got some options here. I have this portion or this factor can equal 0. So I got a 0. This factor can equal 0. So I got an x squared minus 7 equals 0. So x squared is 7, which means x can be positive root 7 or negative root 7. So you've got 3 critical numbers where that derivative can equal 0. Okay, so now we're going to do this one, and this is going to involve chain rule. So if I take the derivative of sine, first of all, the bigger picture is I've got a function raised to the 2nd power. So I'm going to drop my exponent out front, times what's sitting there, drop your exponent by 1, and then times the derivative of the inside. So the derivative of sine is cosine, plus what is the derivative of cosine? The derivative of cosine is negative sine. So it's going to be minus sine. And notice that you are restricted to 1 lap of the unit circle. So this is my derivative. And I'm sorry, I should have gone through our little checklist. Sine and cosine are both smooth. Sine and cosine are both continuous. So the only place I got to worry about for critical numbers are where my derivative equals 0. So I'm going to factor out a sine. And that's going to leave me with 2 cosine x minus 1. So this factor equal to 0. And this factor equal to 0 means I'll add 1, divide by 2. So add 1, divide by 2. So where does sine equal 0? In 1 lap of the unit circle, not including the endpoints. So I would say 0, but I'm not allowed to use it. So pi, I would say 2 pi, but I'm not allowed to use it. And so he's done. Where does cosine equal 1/2? And that's going to be at pi over 3 and at 5 pi over 3. So you have 3 critical numbers for that function. So I have find the absolute extrema. So absolute is the very tallest or very shortest. And it can be endpoints. And this time I'm allowed to use the endpoints. Okay? So this is a function. Is he smooth? Yes, he is. Is he continuous? Yes, he is. So the only place I've got to worry about is where does my derivative equal 0? So the derivative of 9 minus x is negative 1. Well, it's not possible for him to equal 0. Okay, all that tells you is that he's decreasing forever. It's a line with a slope of negative 1. So if I graph this, I'm interested in the interval from negative 2 to positive 4, and I'm not guaranteeing you that this is drawn to scale. So basically, you can just look at this. If you shove in a negative 2, again, the derivative didn't matter because I can't set it equal to 0. But if I evaluate my original function at negative 2, what is 9 minus negative 2? That's a 9 plus 2, which is 11. So if I put in a negative 2, I get an 11, and just from looking at it, you know he's a tall point. So he's a max. Okay, now go to 4. 9 minus 4 is 5. So if I shove in a 4, I get a 5. So he's your low point because I just looked at it. And again, it's not drawn to scale. But I have a tall point, and then I decrease to a low point. So you got a min at 4, 5. You got a max at negative 2, 11. All right, so number 9, absolute extrema on the interval. I have a 4x squared minus a 24x. So he's smooth and continuous. I just got to worry about where does my derivative equal 0. And I'm also on a closed interval, which means I can use my endpoints. So my derivative is 8x minus 24 equals 0. Okay, and then I'm going to solve for x. So that gives me x equals 3. You have a critical number at 3. So I need to test 3 things. Because I'm allowed to use my endpoints, I'm going to test 0. I just discovered my derivative equals 0 at 3. So he's a critical number. I'm going to test him. And then I got a 7. So I'm going to test that one too. All right, so my absolute extrema, well, this is just a parabola that opens upwards. So I know if I have a low point on the interval, it's going to be my vertex. Okay, the other ones will be maxes. So if I shove in a 0, remember we want to know the y-coordinate. If you ever want to know a y-coordinate, go back to your original function. So if I evaluate this at 0, I get 0. If I evaluate this at 3, I'm going to get 4 times 9 is 36, minus 24 times 3 is 72, which is going to give me a negative 36. And if I evaluate this at 7, I'm going to get 4 times 49, I don't even know what that is, should be 4 times 49 minus 24 times 7 gives me 28. So who's the lowest point? This is your min. And it's an absolute min because it's the very lowest point. Where's your max? Well, the very tallest point is going to be at 728. Okay, so that's your max. Which means for these last few, you can do these ones by yourself. So be careful of this one, because you're going to have a cusp. Okay, so you will have a place where you need to include a value because your derivative will be undefined there. So you're going to try -1, you're going to try +1, and then you're going to find out where your derivative equals 0, as well as where your derivative is undefined. So same thing here. 2 would be off limits, but it's not in my interval, so I don't care. So take a derivative, set it equal to 0, and solve. Take a derivative. So I guess we're pretty much good with 3.1. So again, email me if you have questions, and I'm going to hit 3.2.